Hey Apes Kids, this is wetlands essay that we did on Friday. So the first question was describe two characteristics that are used by scientists to define an area as a wetland. Well, the first thing you need to know is that soil is covered or saturated or submerged below the water for at least half or part or all of the year. Okay, so plant vegetation can also have adaptations to allow them to live under those conditions. That they have to be water tolerant. And we call those plants emergent plants. Another characteristic of the soil should be that it's hydric, very wet all the time. B was wetlands are highly productive ecosystems with complex food webs. So here we had to draw a web. And remember, the arrow, direction of the arrow indicates where the energy is going. So the energy from the algae, from the primary producer, goes to the consumer. Okay, so the energy goes this way. Now to earn a point here, all you needed to have was 2 arrows. But if you had 3 arrows total, you got a point, or 2 points. Okay, so look at these arrows. You didn't have to have all of them, but you did have to have at least 3 of them. Okay, the next question was explain why it takes many hectares of wetland to support a pair of eagles. Well, the eagles, this relates back to the trophic pyramids, where the bottom producers have a lot of energy and a lot of biomass, and then the next layer only gets about 10% of the bottom layer, and then the next layer gets 10% of that. So if this is 1,000 units of energy, we're only going to have 100 get passed on, and then we're only going to have 10 get passed on, and then only 1 get passed on. So this little trophic pyramid was what we're kind of getting at for this question. 2 points, 1 point for each correct explanation. So to support the pair of eagles, there must be large amounts of biomass at the low trophic levels. That's here. And less energy is available as you go up the pyramid. If you mention that, that's 2 points. And you could have mentioned some biomass is not digestible at the next trophic level, cellulose, chitin, and you may use the trophic pyramid diagram, but it must be accompanied by an explanation. Okay, next question. For C, what we're looking at is describe 2 economic benefits other than water quality that wetlands provide. Okay, so recreation would be an easy one. And notice that you have to have you have to explain it. You have to get a point for the benefit linked to the description. So benefit and then description. So recreation, but you have to say provides revenue or profits or jobs for the area. You could say stormwater protection. That wetland does stormwater protection, which would reduce the cost of damage to houses or developments, or could reduce the cost for insurance if there's a wetland near your house versus not a wetland. Just like if there's a fire hydrant near your house versus not having a fire hydrant near your house, insurance could go up. You could use it for agriculture. The wetland, economic, back to economic, not environmental, different. You could collect methane off of an anaerobic environment, and that could provide revenue. So we could recharge the groundwater, and which would reduce the cost of water treatment. Next thing we need to do is describe one specific human activity that degrades wetlands. We could convert it from a wetland to an agricultural field. Okay, and then by doing that, we would destroy the habitat in which it is. You know, it says describe, so we gotta provide a description. The runoff of urban areas would be an activity that degrades the wetlands. You know, if you had a lot of sediment or chemical pollutants or sewage or litter or trash that went into that wetland, that's a human activity that would degrade the wetland. Okay, if we logged that swamp, for commercial use, obviously to produce wood, for commercial fishing, if we did commercial hunting of clams in that area. If we diverted the water from that area for our own use, if we dammed it or levied it, or took that for irrigation, okay? If we mined it, if we introduced an invasive species that destroyed it, like in the wetlands in Florida, they put in a python. People release pythons where they would go out, and now there's no natural predator for the python down there, and it's taking over the Everglades. Wastewater treatment plants. This was a tough one. You may not know this one. Primary treatment. Primary begins with P and physical begins with P. That's how I remember it. So primary treatment is the physical removing, trapping of sediments. It could be with a bar screen, sedimentation filtering, or screening it. Okay, now S, how I remember S for the secondary one, secondary treatment. S is for secondary, and what is the second letter of the alphabet? B. So B is biological. That's how I remember that. Biological treatment would be using aerobic and anaerobic bacteria to eat the nutrients out of that. Okay. Question 4 with the, or actually this one's, describe 2 characteristics of the Arctic tundra that make it a fragile, and explain why these 2 characteristics make the tundra particularly susceptible to damage from human impacts. Well, we know that the tundra has a very slow growing season and very low growing season. Okay, it's very small and simple food webs. Okay, and its climate is extremely cold, extremely dry, very short growing season. A lot of it are thin soils, nutrient poor soils, and all of these characteristics allow for, have this slow recovery rates. If we disturb this, it takes a long time for it to come back. Okay, if we cut that into the land or disturb the flora or fauna, we will have a long, it's not very resistant or resilient to change. Resistant or resilient. Slow recovery rates again. Slow recovery rates. Slow growth and decomposition rates. Okay. Last question. This is dealt with the nitrogen cycle. You can find this online if you want, or through the activity that we did before. What we're going for here, 2 points can be earned. 1 point for correct natural nitrogen cycle chemical transformation. So you could say nitrogen is converted to ammonia, ammonium, or nitrate, or you could have written it out. It doesn't matter. If you wanted equations, that's fine. And if you discussed it, said, okay, well, atmospheric nitrogen is converted into terrestrial nitrogen, biologically, or, abiotically through lightning. You could have done ammonia ammonification converts it to nitrates. You could have written it out. You could have talked about ammonification, nitrogen fixation, nitrification, denitrification. So those would all have worked. Nitrate is converted to nitrogen gas. It's really easy, not too hard. This is just the steps to the nitrogen cycle. All right, hopefully that was helpful. If you want credit, write down the right answers, turn them in on Monday.